Hey guys, let's solve LeetCode's daily challenge problem of today, longest path with different adjacent characters. So we were given a tree which is a connected undirected graph and has no cycles, and we have the root at node 0. So then we have like a letter assigned to each node, and we would like to find out the longest path in this tree such that there's no pair of adjacent nodes on the path that have the same characters assigned to them. So for example, 2 and 0, they are adjacent nodes and they both have letters A on it. So we couldn't go from 2 to 0 or 0 from 2 to from 0 to 2. So if we start from node 0, the longest path would be 0, 1, 3, 3, right? And we couldn't go from 0, 1 to 4 either because these two nodes, node number 1 and 4, they both have letters B on it. So in the second example, here like we have A on node 0 and 1, so this is not a valid path, so we can only go from this path, right? So the answer was also 3. So actually this question is quite straightforward, and let's think about of this problem. So first let's think about like if we just have a normal tree, whether it's a binary tree or whatever tree, but we don't have any letters on it, how can we find out the maximum path on this tree? So actually like this is clearly like a recursive question, because if we want to find out the maximum path at root, we need to know the maximum path at its each child node, right? This one, and this one. So let's think about this. If we take this node as an example, what's the longest path that pass through this node? So there are two cases. The first one is like if we consider the case only when this node is a root of a subtree, so which means this subtree. What's the longest path that pass through this node? The answer is actually the longest path is its longest the length of its longest two subtrees plus itself, right? So basically this path 1, 2, 3, 4, 5, 6. But however, if we are thinking about how this node can contribute to its parent, we couldn't return 6 to its parent, right? Because we couldn't go this way and then this way. This is like not a valid root. So actually when we think about what's the longest path a node that a node can contribute to its parent, it has to be its longest subtree, right? The length of its longest subtree. So it means for example this node, it can contribute like 4 nodes to its parents. So for this node, we can get 4 nodes from here and 2 nodes from here, 1 node from here. So actually the longest path is this 4 plus 2 plus 1, this is 7, right? So the longest node root doesn't have to pass the root nodes. So basically we need a global variable to store the longest value of root like this, yeah? And then we will return like how many nodes it can contribute it to its top higher level by using our recursive function. So now let's think about our real problem. Actually you can see like this is a very similar problem to a generic longest path problem. The only constraint is like we have such letters, and for example if we have two adjacent nodes with same letter, we can imagine it like a broken tree, right? If we break the tree from here, break the tree from here, now we have 3 subtrees. All of them are just clean trees without any adjacent nodes that have the same letters. So basically we are breaking down our problem into our generic case. But actually in reality we don't need to break it, right? We just need to check whether a parent, whether like the child of this parent, if they are like if the letters of this child is the same as this parent, we just return 1 from this path, like, right? We just return 1 from this subtree. And from this subtree, as these letters, those two are not the same, we can just return like 1 plus the longest path, let's call it P of root number 1, right? And for this is the same case. Here it's 1 and here like we return 2 including itself, right? Because these two letters are different. So we have 2 here. And now like if we think about the node that passed through this node, it would be 2 plus 1 minus 1, because this node is counted twice, it equals 2. And the longest path it can contribute it to its parent is obviously 2, right? Because 2 is bigger. So here we have 2. So here we have 3 from this subtree. And this is our answer, right? Because here we have nothing. So the longest path would be this 3. Okay, let's using this logic and code it up. So first, we are not given a graph. We are only given like a parent array. So we need to first convert it into a graph. So I will use a hash map where the key is the parent node value and the value is like its children. So I will have a hash map like 0, which is corresponding to a vector of like int 2 and 1, right? And I will call it just a tree. And now first I would iterate through this parent array just to build this tree. So I will check if find parent. If this parent doesn't exist in this tree, I would first place it. Place parent. Let me copy paste. And I need a vector here, so I will declare vector int e, and I will push back the child value, which is just I, right? So if this node already exists in the tree, I would just I would copy this. I will just push back the I into its existing vector. So I think we are done for this tree. And now I would build my recursive function, but first let's have a global variable which records the longest path globally. And I will call it DFS. So we need to pass in this string definitely, and we need to pass in by reference, otherwise we will have time limit exceed. So now I need a current node and a char maybe. Let's call it C. Okay. So now first I will define the current path and the longest path of current node and second longest path of current node's child subtree, right? Sorry, I will call it second p is also 1. And now we can loop through the vectors. So tree node go over all its children, and now we would check if this one, right? If the character here is not equal to our C, then we would do path equals 1 plus subtree, right? So subtree would be this string will remain unchanged, and this would be the new node, right? And our new char would be this one, yeah? So great. And otherwise we still have to loop through the tree, otherwise we will have unvisited nodes, and then our path is just equal to 1. And then I will update the max and second p. So if our path is greater than our max p, I would first update now our max p, the second p would be equal to max p, right? And then our max p would equal to path, and other case is if our path is greater than second path, our second path would just be path, right? Great. So now we can have our current, the max length of our current route, which is our max p plus second p minus 1, and we can now update our global value, so it would be max current. Great. So finally here we can return the longest path of this node to its parent. So I think it looks good right now, and we can call it here. So we need our string, node, and current character, and then we can return our result. Yeah, great. Let's check whether it works. Unordered look. Parent oh, okay, sorry. I forgot to write the condition here. So okay, great. Missing semicolon, as always. Oh, great. We passed our 2 test cases, so now let's try to submit it. Wrong answer. Output 0. Oh, I think so. Yeah, first, because like one node is also like length of 1, so let's initialize it as 1. I think now we are fine. Should be great. Great. Yeah, as you can see, we passed all the test cases, and as we only need to iterate through this tree once, so our time complexity would be O of n. Yeah. So thank you for watching, and